We're going to walk through the mechanics of the dihybrids because on the air test there's been a dihybrid punnett square every year. They think monohybrid, and it's true, the state standards say that monohybrid punnett squares are a middle school standard. They're not going to assess you on those because you should have been assessed on those on the 8th grade test. And I've looked at the 8th grade test, and they do a pretty good job if the sample tests that I've seen are any indication. So we are going to go through just the mechanics of the dihybrids. You know that you're crossing how many traits in a dihybrid? 2. 2 traits. Di means 2. So let's, actually, you know what? We're going to do one that's sort of a classic. So it's a flower that can be purple or red. And the pollen grains, so remember that's the plant sperm, can be long or they can be round. So the pollen characteristic, long, L equals is the dominant, that's long grain. Little l is the round grain. And in flowers, I think, well, we're going to do red as the dominant, though I'm not entirely sure that's correct, but it doesn't matter. And so little r is purple. Okay? So those are the traits that we're working with. You should write this down, right? Yeah. So what if we have 2 parents who are heterozygous for both traits? Then let's write the mother's genotype and the father's genotype. Remember I said heterozygous for both traits. So you go ahead and write it down and we'll compare notes. Okay, is that what you have? Heterozygous for both traits. So now the big question is, what combinations of alleles are possible in their gametes? Okay, well, and it doesn't matter if it's the male or the female, I guess, because they have the same genotypes, so the combinations possible are going to be the same. There's a 50% chance that any given egg is going to get a big L. There's a 50% chance that any given egg or sperm is going to get a little l. For every big L egg, there's a 50% chance that it's going to get a big R and a 50% chance it's going to get a little r. For every little L egg, 50% chance it's going to get a big R, 50% chance it's going to get a little r. So the 4 possible combinations in our gametes: dominant, 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 recessive, recessive, dominant, recessive, recessive. Good so far? Okay, these are the same combinations possible in the eggs and the sperm. So in the flower ovary and in the pollen, since we're talking about plants here. So now how do we show the possibilities that exist in a Punnett square table? Okay, so I've set up a table. Since this is dihybrid, I need 16 squares, because for each parent I've got 4 possible combinations of alleles. And I'm going to list those: big L, big R, big L, little L, big R, little r. And since we said the gamete combinations are the same for both parents, we get that. Now, the next part is the part that I could train a monkey to do, and that's just drawing those letters down in, making sure you keep the alleles for each trait together. I'll give you a minute to get that done. Okay, are you proficient at pulling these down into the spaces? Can you get the combinations? Okay. Now, as I said, I could train a monkey to fill in the chart, and you're all much smarter than a monkey. What we need to do is find genotype and phenotype ratios. So it's really cool because if you list them in the way that I do, a pattern starts to emerge. Ooh. So I'm going to list all of the possibilities with a dominant homozygous dominant for the pollen first. So big L, big R, little r, big L, double homozygous dominant, big L, big R, little r, big L, little r. Okay, so that's my first set. Then I'm going to list all the big L, little l, and that comes with big R, little r, little r. Then we're going to go for the little l's. Big R, little r, little r. Okay, cool. How many, so here's the pattern I want to talk about. If you notice carefully, where do you find all of the genotypes that have big L, big L? Oh, look at that. They're all up in those 4 blocks. That simplifies life. So of those 4, how many have a big L, big R? 1. How many have big L, big R, little r? 2. How many have big L, little r? 1. Okay, so 1 to 2, Gesundheit to 1. Now, if we look carefully again, and I love that I have the ability to color code. Where do we find big L, little l's? Well, this corner, and where else? The lower opposite corner, caddy corner. How many are big L, big R? 1, 2. How many are big L, big R, little r? 4. 1, 2, 3, 4. And 2. Yep, you got it. You're ahead of it. So these last 2 are big L, little r, little r. Oh, look at that. 1, 2, 1, 2, 4, 2. If you were a betting person again, what would that last ratio be? 1, 2 to 1. So let's go ahead and finish it out. So how many little L, big R's? 1. How many little L, big R, little r? 2. And how many, I gotta find one more color here. I'll do this mud color. Big, little L, little r. Just 1. Easy. It works as long as you lay out the pattern like that. So we don't, with the monohybrids, we actually do say things like, 1 to 2 to 1 and 3 to, 4 to 0. It's a little cumbersome to say 1 to 2 to 1 to 2 to 4 to 2 to 1 to 2 to 1. A little much. What we talk about more often and what really matters more in the long run is the phenotypes for these things. So what are our possible phenotypes? Well, remember that we had red flowers and purple flowers. And we had long pollen grains and round pollen grains. So we had long pollen and round pollen. So our possible combinations, and I'm going to shrink the actual Punnett square itself now. Our actual possible combinations, and we went with the pollen size first, are long pollen with a red flower, and long pollen with a purple flower, or short pollen or round pollen with a red flower, or round pollen with a purple flower. And I will go ahead and write those out, because I don't want it to be all visual. Okay, so the only way to really do this is to look at each of those genotypes and ask yourself, is this long pollen or short pollen? And so if we start with all of these, let's start off by just asking, is there any pattern to the pollen size? First off, everything here is long pollen. So, of those, how many have red flowers? So, what color are the flowers on this long pollen flower? Red. So that's one. What color are the flowers here? Two more. Okay, what color are the flowers here? Purple. So we'll put one there. What color are the flowers here? Red. So that's two more. What color are the flowers here? Red. So that's four more. Okay, and then these last two here, those are purple. Okay, so everything else on this table, these guys are all going to be our round pollen grains. So, what color are these flowers? Red. What color are these flowers? Red. And our last little one here, what color is the flower on that plant? Purple. So, what's interesting to note, set that aside, is that we're more concerned, so we got 9, 3, 3, 1. Well, you have to be told that. So in this case, I told you that long pollen was capital L, so that's the dominant. You can't, well, there are ways to guess at that, but you can't just know it. So in these kind of problems, you always are told what's dominant, what's recessive. Or at least what's dominant, and then you can figure out what's recessive. Whoops. What we're most interested in usually, so remember we said like, well, what percentage of offspring would have the recessive phenotype? What we're interested in here is usually percentages. Like what percentage of these offspring would have both dominant characteristics or both recessive characteristics? So how do you find the percentage? So we know we had 16 possible combination, or 16 possible starting. So we're going to divide everything by 16. So 9 divided by 16 gives us 56%. And I'm rounding. These numbers are a little sloppy. 3 divided by 16 gives us 19%. So we get that for both of those. What about that poor one lonely recessive individual? There's one in every family. Actually there are 6% of this species we would expect to show both recessive characteristics. So when you look at a graph, and this is when these characteristics are, there's no connection in the way they're inherited, you're just as likely to get either copy of either gene, they don't travel together in any way. When you look at something and it says 56% of the population shows dark hair and pointy ears, would you assume that both of those are the dominant alleles? Yeah. And that's one of the ways that they can get these kind of problems, is coming out sort of from that backside. You know, only 6% of the population shows light fur and curly tails. Would you assume that light fur and curly tails are dominant or recessive? Recessive. You know, that's the kind of numbers they're looking at. All right. Do you feel better about the dihybrids, walking through another one together? Okay. Your homework is finishing the other dihybrid. You should have done one coming in today. If you didn't, you now have 2 for homework. And answering the questions on the back. Okay? When you walk in tomorrow, and you're going to have about 15 minutes to actually work on these in class, so that's good. When you walk in tomorrow, there will be a quiz on dihybrids. because then we got to start talking about all the other possibilities, like, oh my gosh, sex-linked. And how many of you, well, I'm going to do a pre-assessment on incomplete dominance and codominance and all that. I'm guessing you guys didn't have much of that. Okay, we're going to talk about those. So right now, work on your dihybrids.